Hello again, welcome back to ACS 4390. Today we're going to talk about GraphQL schemas and types. In the previous video we covered the query language, and you can follow all that here in the class syllabus, okay? So right now we're on lesson number 2, and everything in the slides that I'm showing is in the lesson 2 lesson page, right? Okay. So a schema defines what your GraphQL API can provide to the world. Today we're going to look at GraphQL schemas and types and the schema language, and we're going to implement a server using GraphQL and GraphQL Express. So you'll make your own server today and define your own schemas, and then you can run your queries against your server. The learning objectives for today are define a GraphQL schema, use the schema language, define a GraphQL resolver, and then use queries and use the graphical browser. As a warm-up question, you can try this with anybody, and we'll do this in class. Compare GraphQL and SQL. So if you've used the SQL language before, now when we're looking at the GraphQL language, like how do they compare? Here's a review, and you can try these review questions on your own. These are questions that cover material in the previous class. Can you describe what are the advantages of GraphQL over REST? Okay, and then I have a couple query problems here, okay, and you can use the Swappy API to try and answer these questions. So who is person number 10? What is their name, eye color, and height? Okay, what movies did person 10 appear in? What's the total count, and what are the titles, right? What vehicles were they in, and how many vehicles, and what were the names of the vehicles? Okay, so if you can answer those questions, you've got the material from class 1 covered. So let's talk about the GraphQL schemas now, right? So a schema contains a set of types that describe everything you can query from the service, okay? So when you're making an API, your schema is going to say what your service can provide to the world. Schemas are written in the GraphQL schema language, and this language, it's similar to the query language, but it's a little bit different, but they match up. So like when you write a query, that query has to, work against the schema, right? So if you're querying for something that doesn't exist in the schema, you're going to get an error, right? In the Swappy API, they might define a person type in their schema language like this. They might say type is person, and then name is string, and eye color is string, right? So this is written in the GraphQL schema language. The exclamation point here says that a value cannot be null, and string is a type. So name for a person always has to be a string type, and it can't be empty, is what we're saying here, okay? You can use other types too. So you can use int, float, and collection. So a collection is like an array, but everything in the collection has to be the same type. So for example, here we could say height is an integer, and films is an array, and every item in the film array is a type film, okay? A film type. So somewhere else you might define a type called film and then give it some other properties. So GraphQL includes these default types. It's got integer, float, string, boolean, ID, and the collection type, which is the brackets, okay? Right, and then of course we can define our own types that use these types, okay? So like we made person on the last slide, right? Here's another example. Like if you were making, let's actually talk about collections here with this example, right? So this is called my type, right? And it's got favorite numbers, favorite foods, favorite websites, and favorite favorites, right? So how does this work, right? If I say favorite numbers, this is going to be an array, right? And it has integers in it, okay? But this value, since it doesn't have an exclamation point on the outside here, then it could be null. So in other words, my type might not have any favorite numbers, like favorite numbers might be null, right? It could be the empty array, or it could be an array of numbers, okay, of integers, right? But since I put the exclamation point here, none of the values inside the collection can be null. So this would not be allowed. Like I would not be allowed to put a null inside the array, okay? Or my server would not be allowed to return a null, it would throw an error, okay? Favorite foods, right? So in this case, I put the exclamation point outside the collection and inside on the type, and that means that favorite foods always has to return an array, okay? Always returns an array, it's never null. And when it returns the array can be empty, or it could have a list of strings in it, right? But it cannot have any null values, right? So this would not be allowed, cannot have a null, because I have an exclamation point here, okay? And it has to return an array, okay? In the case of favorite websites, I have to return an array, right? So it has to be an array, can't return null, and then I could return a list of things, but I could have a null in the list, right? Because I don't have the exclamation point here on the type, right? And in the last one, we could return a null, we could return an empty array, or we could return an array that might have some empty or null spaces in it. So what about a recipe type? So let's imagine you're making a website that's, serving up recipes, and you might define a recipe type for that, and every recipe would have a name, okay? And I put the exclamation point here because every recipe has to have a name, right? Can't be null. But maybe some recipes don't have a description. So in that case, we can say if it does have a description, it'll be a string, but there's no exclamation point, so it could possibly be null, right? So there's some empty, maybe the database doesn't, it doesn't require us to fill in this field. A recipe might have a list of ingredients, right? So here I said the list of ingredients, each ingredient is going to be a string, and it must be a string, it can't be empty, right? And we always return a list, right? So it can't be null instead of the list. Maybe there's some other types. So what types would you use here? What if we had an is spicy for the recipe and an is vegetarian? What would the value be? Let's talk about enums now. So an enum is a list of things, okay? So GraphQL supports enums. A lot of languages support enums, right? You can think of the enum as a list of values, or it's named value types, right? So you might have a list of numbers or I don't know, positions, right? You might have a list of fruits, right? You might have a list of moods. You might have a list of characters, right? And that's okay. It's a fixed list. So enums don't grow or shrink in lists. They always have the same number, right? And the same members. Let's actually define one with GraphQL Schema, right? So here is enum meal type. So imagine our recipes have a meal type, and the meal type is like the breakfast, lunch, or dinner, right? So in this case here, I have an enum as a meal type, and then down here on the recipe meal type, it's type uppercase meal type, right? And it can't be null. And this means that the meal type here for recipe can only be breakfast, lunch, or dinner. It can't be anything else. And notice you don't use the quotation marks around the enum. Okay, why don't you write your own enum right now? So imagine you're making a diet type for your recipe, and you need to set an enum for omnivore, paleo, vegetarian, vegan, or insectivore. What would it look like? You can stop the video and do this on your own. Okay, so here's an answer. How does your answer compare to mine, right? I've got enum diet type, omnivore, paleo, vegetarian, vegan, insectivore, and then I have type of recipe, and I set the diet type to diet type, right? So that means diet type can only be one of these 5 values. Let's talk about interfaces now. So GraphQL schema language supports interfaces, right? An interface is a description or a contract that describes types that conform to it, okay? So it's also a type in itself. So imagine like we had some characters from the Star Wars films, right? And our characters could be either humans or droids, and humans and droids have different fields on them, right? So they're each a different type. So you can see here that I've defined a type called human, and I've defined a type called droid, right? And humans have name, eye color, and films, but droids have name, films, and primary function. So it's a little bit different, right? They both share name and films, right? And as you saw earlier, if we have a collection, we could make a collection of humans or we could make a collection of droids. But what if you had a film and your film needed to have a cast of characters and the characters were mixed? They were droids and humans, right? So in that case, we could create an interface called character, and a character can have a name and films that they're in, right? And notice that human and droid both have name and films, right? They both share this, right? So what we could do is we could say human implements character, and that means that we could create a collection of character type, and we could put humans in that collection. And since droid also implements character, then droids could also go into any collection that was typed character. Okay, so this interface right here is a contract that says that anything that is typed character has a name and a film. Or actually, it's a little more specific because it has a name that's typed string and films property that's a collection of films. Okay. So, like I said, the interface is also a type. A film type might have a cast, and then it could be a collection of characters, right? And so this character is an interface, but we know that humans and droids both match the character interface, so we could put humans or droids into this collection. Okay, great. So now that we covered all that, let's actually do it on our own, right? Let's actually create a real server that uses these ideas, right? We're going to use Express for this example, okay? So we're going to create a GraphQL Express server that implements, our schema that we write. So to set this up, what you're going to do is you're going to create a new folder, and then you're going to initialize a new Npm project, and then import your dependencies, right? And then create a new server.js, and then we'll write all our code in the server.js. So we're going to keep our server pretty simple at first. So I'm going to go and create a new folder here. I already did this earlier, but I'll make a new one, right? So I'm going to make a new folder here. Let's call it Express GraphQL. How about that? Oops, wait, I already got a name. I already used that name. Never mind. Let me do example GraphQL. Actually, let's call it example server. How about that, right? Okay, so I'm going to open this up in Visual Studio and then arrange my windows here. And I'm going to use the terminal in Visual Studio, and you can use the other terminal if you want. It doesn't really matter. So first of all, we're going to initialize an npm project here. So I'll say npm init-y. Right, so let me zoom in on that, right? So I got npm init-y, right? The -y just says yes to all the questions because it'll ask me, like, what do you want to name your project? What's the description, right? I just said yes to all the questions, right? And it made a new package JSON here. So the next step is to import our dependencies. I'm actually just going to copy this line so I don't have to type it all out, and I'll paste it here, right? So I'm going to import, I'm going to do npm install, save, and then I'm going to import Express-GraphQL, and GraphQL, okay? And you'll see how we use these libraries when we build the server. Okay, great, so that's all set up, and then I'll create my server.js. So let me make a new file here and save it as server.js. And all our work is going to happen here. You should include a .gitignore because this is going to be your homework assignment, and to submit your homework you should have a gitignore. So follow this link and create a gitignore for your project. Next, let's actually go into the package JSON and add a start script, and this will just facilitate our work and make it a little faster and easier to get this project started. So I'm going to go to the scripts tab here and add in a start script, and I'm going to use nodemon server.js. If you don't have nodemon installed, Google nodemon and follow the installation instructions, right? So nodemon's just really great. You can run this with node also if you want, but I'm going to use nodemon because it's super convenient. Okay, let's go back to our server.js, and now what are we going to do? So let me walk through the process that we're going to use here. Let me actually arrange these windows a little bit. So the first thing we're going to do is we're going to import our dependencies. Okay, so we've imported Express to run the Express server, and then we imported Express-GraphQL, okay, because we need that to turn our Express server into a GraphQL server, right? So it can understand our GraphQL, requests and the schema, right? And then we're going to use the GraphQL library to build the schema. So we'll pass a string that written in the schema language, and it will create an object that can be used by the GraphQL server, okay, or the GraphQL Express server. Okay, great, so that's good. Now let's create a schema. So here you can see that I'm using build schema, right? So I'm using build schema that I imported, and then I'm passing into this method, right? So it's got the parentheses here, but inside there I passed in a string. So there's the backtick here, so I can write a multi-line string, right? I need to write this out in the schema language, but it's all written as a string. So here I've defined a type and I've defined a query, okay? So here in the schema language, and this, by the way, it returns a schema object, and you'll see that we'll use that when we get to this GraphQL HTTP, right? Okay, so we'll give that to GraphQL HTTP later. But the schema that I've written here defines two types. It defines an about type that has a message field that is a string, and it defines a query type with getAbout that returns an about type, okay? So what is going on here, right? The query type is special, and it defines the query types that we can ask for, okay? Right, and then this other type is just a typical type, and we could use this in multiple places, but the query type is special, and it's where we handle queries from GraphQL, right? Okay, now we're going to define a resolver. So a resolver is what handles a GraphQL query. So when you send a query to the server, it runs through the resolver, and the resolver figures out like what the actual values are. So notice here that the schema has a query type, and we have to list all the query types here in our resolver. So resolver is just an object that has properties here, and these properties at the root level are going to match our query type, and those properties, the values for them is going to be a function, and that function will return the type for this query, right? So this query is an about, it returns, or it is getAbout is a query that returns an about type, right? And so this object here that getAbout is returning in the resolver has to match the about type here, right? So getAbout is returning an about object, so this getAbout function here has to return an object that matches the description here. So this has a message property that has a value as a string, right? So I have message here, and I have a value that's a string. So this is where I'm getting the actual value here. This is just describing what types the things are, okay? Next, let's start our Express server. So I'm going to create the Express server, right? And this is boilerplate Express. Next, we're going to create a route, okay? So this is the endpoint. This is where we define the endpoint. So when you communicate with the server, you're going to communicate at /GraphQL. That's going to be the endpoint for our GraphQL, API for this project, right? Notice here, we're going to say GraphQL HTTP is going to handle requests to this route, and then we pass in an object that has options that configure the HTTP server. So in these options here, I include the schema from above that we used build schema to create. So I use the schema object, and then I use the root resolver here, and I set it as root value. So this is my resolver here, right? And then last, there's an option here that turns on the graphical browser. So remember when we were using that online tool, I called it GraphQL, right? This enables that for our server, so we can use that when we run our Express server, okay? So I turn that on here with true. Okay, next. Let's start our app up. So I'm going to do, this is boilerplate Express stuff, so we're going to define a port that we're going to run on, and then we're going to listen at that port, okay? So I'm going to save this, and then we're going to run our server. So what you're going to do to run your server is you're going to use npm start to start the server, and then you'll go to localhost 4000/GraphQL in your web browser. Okay, so let's give it a try. I'm going to open up the terminal here and do npm start. You can do node server.js or node mod server.js too. Great, and if it says running on port 4000, everything is working. So let's go get port 4000, right? Oh, yeah, wait, port 4000/GraphQL. There we go, right? Ah, there we go. So here's my GraphQL server, and let's see what it says, right? Actually, I was playing with this earlier, so I have some other queries in there, but let's write a query. So our server that we defined has a single query called getAbout that returns an about type, right? Let's put that in here. Notice as I start typing, the introspection in GraphQL tells me what's available. It tells me that I can only do getAbout, so I choose that, right? And then getAbout has returns an about type that has a message field, so I can get the message here. And you can notice that this matches, right? If I say getAbout, it returns an about, right? So this would be my about object here, and about only has the field message, okay? So if I save that and then I hit run, you can see that it gives me data, getAbout, gives me the message of hello world, right? And that's the value that the resolver returns. Okay, so now we've got a simple GraphQL server setup. Let's try a couple problems or a couple examples with this, right? So here's our query that we just ran, right? And if everything's working, you should see what I saw, right? Okay. Let's see here. So I kind of talked about those. Let's go on, right? What if we want to add some more stuff here? I'm going to skip over this. I kind of talked about those, right? Let's talk about the resolver. And what if we wanted to add some more features to our server, right? So the resolver is responsible for resolving a query, right? And resolvers can be hierarchical. So if you have nested types, they can look up the things that, from, look up like the films for a character, right? But we'll do some of that later in class, right? For right now, we're going to keep it all kind of top level, right? Okay, here, when you call getAbout, it's going to return this object, and this object has to match the type that getAbout returns that we've defined in the query, okay? Let's try it now. So you're going to try this on yourself, or try this for yourself and see if you can solve some problems. So what if you want to define a new type called a meal that has a description that's a string? Let's do it. So I'm going to go up here and add the meal type to my server. And then I'm going to add a new query, right? So I'm going to say get meal. So I'll say down here, get meal, right? So now my server can return a type meal. Notice I didn't put the exclamation point so we could possibly return null, okay? Now let's add something to the resolver to actually resolve that, right? So I'm going to go to my resolver here, and where's my resolver? There it is, right? And then there we go, right? So now if you call get meal, it'll return noodles, right? So meal type has a description that's a string, and then this object that's returned has a description that is noodles, right? Let's give it a try. So I'll go to my server. I noticed that even though the server here on Express updates, sometimes the browser here, you need to refresh it to get it to recognize a new query. So like if I do get meal, like doesn't show up, but if I refresh it, then it'll show it, right? So I'll do get meal, and then I'll get the description for the meal, right? And then I see noodles there, so that's working, right? And I could get about and get the message, right? And then I got my two results there, okay? Okay, in some cases, you'll have to provide information to get the information that you want, right? And this happened in the Star Wars API, like you had to provide the character ID in order to get the particular character that you were looking for, right? So we can set that up with our schema. We can provide arguments, right? So let's talk about that, right? So let's imagine that your meal had a different, meal time, like breakfast, lunch, or dinner, and so you want to return a different meal depending on which time was provided, right? Okay, so to do that, what you're going to do is you're going to go into your query type, and when you define get meal, you'll put the parentheses here and you'll add a parameter to it, right? So notice how this looks a lot like the query, okay? But remember, this is in the schema language, right? So in my schema up here, I'm going to put parentheses there, and then I'll say, time, and then let's say time is a string and you must include it, right? And then what we're going to do now is handle that in our resolver, right? So in the resolver, you'll see on get meal, we're going to take in the parameters in the function, right? So it comes in as an object, and each parameter is a property on that object. So we can deconstruct them here, and then we can, use that parameter to determine what we return. So in my case here, I just made an object with the different meal times as properties, and then we match the time against the property name here, and then return that particular meal string. Okay, so let's give that a try. I'm going to just copy this. Actually, let's just copy that and we'll paste it, right? So let's try that. I'm going to replace this here and kind of fix my formatting there, right? Okay, and then I'm going to go back to my server here, and I think I'll refresh it really quick just to make sure that it's all working. And I'll type get meal, parentheses, and notice it code hints me for the time, and it wants a string, and you got to use the double quotes here. So let's do lunch. That's the best meal of the day, and then we're gonna have a property here. I'll get the description, right? And it returns noodles. What if I said, breakfast, toast, right? And then we could try dinner, pizza, right? What if I put in a different time, like snack, right? I do snack time. Oh, I get an error, right? Because it doesn't match one of the properties, right? Okay. So let's put that back at dinner, right? And then let's move on, right? So I got some challenges coming up, right? So that's kind of the basic idea. Let's actually do a quick review there, right? So what happened here, right? We imported our dependencies, we defined the schema as a string, and then we used a function to turn that schema into something, right? So there's a little magic happening here that's creating the schema object, okay? Next, we made a resolver, okay? And the resolver is going to handle all of the queries that you have here, right? So it can resolve any of those query types, right? And it should always return something that matches the description in the schema, okay? Next, we set up the server, right? And then we created an endpoint for our GraphQL server, right? So we have GraphQL HTTP, and then we pass it the schema and the resolver, and then we turned on Graphql, and that's why we get this special interface here. Okay, so you don't have to have that on, but it's great for testing. Okay, so here we already actually tested this, so that was working hopefully for you, right? And let's try another one. Let's imagine you want to use, since I only have these 3 types right there for the meal time, right? It's just breakfast, lunch, and dinner, and Enum might be a great choice here. Let's see what that looks like with our schema, okay? I'm going to go into my schema here and do Enum, mealtime, and then I'll say, breakfast, lunch, and dinner, okay? And that means that down here, the time can also be replaced, replace the string here with a meal time. Okay, let's say that must be included. Okay, right? Oh wait, so let's actually test that out before we go on, right? So we just did this here. So that means now that you can only include the things from the enum, right? So let's give that a try. So you'll notice before when I put snack time in there, it didn't like it and we got an error, right? Let's refresh here and see what happens, right? So here you can see I'm getting an error and it's saying like, hey, enum meal type cannot be represented by a non-enum value, okay? So what I'm gonna do is I'm gonna replace dinner here, the quotation marks, and I'm gonna type in dinner like this without the quotes. So since this is an enum, we can remove the quotes from it and just use the word. Okay? So this, I run it and I get pizza, right? And you'll also notice that it gives me the code hints, right? So if I type L for lunch, it gives me lunch, right? If I type in an E, it gives me breakfast and dinner, right? Okay, so now that it knows what possible values can be used for mealtime, then it can code hint us for those. And that's the introspection that GraphQL also provides, right? Let's put lunch back in there because noodles are amazing, right? Okay, great. So let's move on to the next section. This is the challenge section, right? Oh, wait, I guess actually I did collections too. Let's do collections and then we'll have some challenges coming up, okay? So let's imagine that you'll want to work with collections at some point, right? So, collections can be a list of posts, a list of users, a list of foods, a list of pets, albums, music, like anything, right? Okay, anything that comes in groups, right? So let's imagine that we want to, I'm going to close this thing up right here, right? Let's imagine we want to create a pet type, right? So I'm going to add a pet here. I'll say type pet, give it a name. Every pet must have a string name and a species, which is also a string. This actually could be an enum also, right? But we'll do it as a string. And then what we want to do is we want to have a query that gets the pets. Now, imagine you have a list of pets, right? So we're going to have a collection of pets. Notice all pets is a collection, right? So let's add that in now. So I'm going to go down to my resolver. Or no, actually I got to go to my query first. Sorry about that, right? We got to set up the query type. So we'll do get pet. And imagine, since we have a collection of pets, maybe just like this Swappy API, we could include an ID and get the pet that's at a particular ID, right? So we'll put the parentheses here and say ID and make this an int. Okay? And it should return a pet. I didn't put the exclamation point here because if we give it the wrong ID, then it may return null. So I'm going to leave it like that. And then I'll do all pets, right? So that's going to return the entire collection, right? And so we don't need any parameters here, and we can just say you're going to be a list of pets, okay? And you'll always return an array, and there can't be any null objects in there. Okay, now we're going to handle the resolver, okay? So I'm going to go down to my resolver here, and we've just added two new query types, so we're going to put those into our resolver here. So I'll say get pet. Oops, and we'll make this a arrow function, and this has an ID property, so I'll deconstruct to get the ID. And now we're going to return the list of pets. So I don't have this pet list yet. We're going to define that in the next step. But imagine you have an array called pet list, and you're going to return the pet that's at the index matching the ID. Okay? So imagine the pet list array is just kind of like we're mocking up a database. So we'll do some database stuff later, but for right now, we'll just keep it simple by making it just like kind of in memory, right? Next, let's handle the all pets query, right? So all pets doesn't take any parameters, and it's going to return the entire pet list, okay? And now let's define our pet list, right? So I'm going to copy this, right? And I'll paste it up here. So imagine I have a list of pets, notice that my list of pets are objects, and every object matches the pet type up here, right? Because it has name and species. And since I'm going to make an array of pets, then this array here is, in order to match that, has to, look the same, right? Has to have the same properties, and they have to have the same types, okay, as values. Okay, and then we can get a pet here, or we can return the entire array. So let's give that a try now. How would we get at a pet, right? Let's give it a try. So here's a couple queries you can try. Let's take a look over here. I'm going to refresh this also, right? And try a new query. Let's do get. Let's actually do all pets, right? So all pets returns a list of pets. Let's get the name of all the pets, right? So I get Fluffy, Sassy, and Goldberg, right? What if I want to also get the species of the pet? So this is a dog, a cat, and a frog, right? What if we want to get one pet? I'll say get pet. Now this takes a parameter that's an ID, and it has to be an integer. I'll get pet 0, right? So that should be Fluffy, and it should be dog, right? So I'll type in name here, and we'll say species, right? So we get Fluffy. What if we get pet number 1, right? Pet number 2, right? Seems to be working. What if we get pet number 3, which doesn't exist? But that's okay, because our collection type here can be null, I think. Yeah, like this one can return a null, right? So if I say get pet and the ID is incorrect, this doesn't have the exclamation point. If I put the exclamation point there and then refresh my server, it's going to give me an error saying like, hey, you can't return a non-nullable, right? Okay, so there we go. So now let's get into the challenges, right? So you're going to try these challenges on your own, and you should be able to do them with all the material that we just covered, okay? So I'll let everybody read the challenges on their own, but I'll just go over them really quick. But you're going to create your own array of objects, just like we did in class. Name, right? Species, age for pets. You could do songs, title, genre, length. You can pick your own array of objects, right? So you do your own thing. Could be movies, could be a list of vehicles, could be a list of, I don't know, whatever you want to do, right? Books that you read, okay? And then you're going to make a type in your schema for it, right? You can use the stretch challenge here is use an Enum advanced, use the interface, okay? And then you can continue with these challenges. They all kind of build on this idea, right? So the next one is to query the type, set up a query, right? Use a resolver, right? So set up a resolver that returns your type, right? Use GraphQL or the graphical interface and test your work, right? And then make another query that returns one thing at a particular index. That's kind of what we just did, right? And the challenges go on from there. So you can keep going. They kind of build, right? So I think there's about 15 of these, right? So you can work your way through these. Maybe there's 16. There's a lot, right? So work your way through these, and they kind of build, so they get a little tougher as you go along. So again, thanks for watching. I hope this was interesting and kind of gets us into building GraphQL schemas. Okay, so see you later.